All right, today I need your undivided attention. You might have to watch this video more than once. This is where pre-calculus starts to get complicated, and it just takes a little while to let this information sink in. Okay, we're going to start. We are still in Unit 2. We're the second day of Unit 2, and we reviewed, hopefully you watched the review of special right triangles before you started this video. So if you haven't, please stop, go back and watch the quick review of special right triangles, and then you can start this, okay? Because we are going to start the unit circle. It's a circle that's centered about the origin with a radius of 1. I talked a little bit about this when we were doing conversion of units from degrees to radians. We use the unit circle to help us evaluate trig functions of special values, and there's 16 of them, and they're created from special right triangles. So we're going to go ahead, and you don't have to memorize the entire unit circle. You only really have to memorize the first quadrant. And I'm going to show you how these values are taken from the unit circle. Okay, so if you just look at this right triangle right here, okay, if I create myself a right triangle, if we know this angle is 30 degrees, this angle has to be 60, right? That's a 30, 60, 90 triangle. We know the relationships between the short side, which is this side, I'll put a little s, and the long side here, and this side is the hypotenuse. We know those relationships. If we have them memorized, we should, and I know it's been a while since geometry, but you just need to know them, are everything revolves around the length of the short side. Here's the short side. Okay, so we're given the hypotenuse. So if we know the hypotenuse is twice as big as the short side, that means if the hypotenuse is 1, since the radius is always 1 in the unit circle, then the short side has to be 1/2. And then the long side is the short side times the square root of 3. So when you take the square root of 3 and multiply it by 1/2, you get √3/2. Okay, now if I wanted to write down this ordered pair, with my x value and my x value would be √3/2, and my y value would be 1/2. Done. There you go. Okay. Now moving on to different color. 45 degrees. If I draw myself a right triangle, this is a 45, 45, 90 triangle. The relationship between the two legs, those are the same measures, right? The relationship between the hypotenuse and the short legs is if I take the hypotenuse, which is 1, and I divide by the square root of 2. So if I take 1 and divide by the square root of 2 and then rationalize it, I get √2 over, √2 times √2 is just 2. So I get √2/2. So the legs, the x and the y distance, are both √2/2. And now this is a 30, 60, 90 triangle, but the x and the y coordinates have been flipped, right? Because now the short side and the long side have changed places. So this ordered pair has been switched to 1/2 and then √3/2. Now, if you're not already writing this down, I would suggest you get a blank unit circle and start filling it in with these values, because we are going to go straight to a much larger unit circle here. And the reason why we counted last block in terms of halves and thirds and fourths is because of the unit circle right here. So we just filled in, so go ahead and fill in the quadrant 1. Okay, so we know that this ordered pair right here has an x value of 1 because the radius is 1, and we didn't go up or down, so y is still 0. Okay, and here the x coordinate is 0 and the y value is 1. Again, radius is 1. So I'm going to go ahead and fill in the rest of the degrees in this circle. So notice that we have what I call short angles here, and those angles are the same measures away from each other. You'll see that in just a second. And then we have the medium angles, which cut the quadrants perfectly in half, and then we've got the tall angles. Okay, and these are all related. So if we can figure out the measures in quadrant 1, we can just reflect that and figure out the measures in the other quadrants, okay? So you see how between 0 and 30 degrees, this is 15, this is 15, this is 30, okay? We're just going to go around the circle and fill in the rest of the degrees. So let's do that. So the next one after 90 degrees would be one, let me get blue. And you might have to pause because I might go a little fast for you. 120, 135, 150, 180, then another 30 degrees, 210, and then 225, adding 15, and then we know that this is 270. We've seen that before. Okay, plus another 30. I like doing quadrant 4 because these are easy. 300, 315, 330. Whoops. 330, and then all the way around is 360 degrees or 0 degrees. Okay, so those are the measures of the angles for the unit circle for all the 16 special angles. Okay, so moving on to radians. Now, I'm going to do this in orange here. Okay, so if we look at sixths, if I break up the unit circle, oops, oh my God, what am I doing? There we go. Okay, so we'll just start with this top half into 6 pieces. So here is 1, that's 30 degrees, 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 that's 30 degrees. So this is pi, right? What we need to do is if I take pi and cut it into sixths, then I can fill out all my angles here in radians. So I'm going to go ahead and do that now. So we got pi, right? This one, first one, is pi over 6. It's just another way of writing 30 degrees. So if I add another pi over 6, I get 2 pi over 6. Simplified, that's pi over 3. This is 3 pi over 6. 3 pi over 6 simplified is pi over 2. 4 pi over 6 simplified is 2 pi over 3. 5 pi over 6 can't be simplified. Let's keep going around. 6 pi over 6 is equal to pi. 7 pi over 6. 8 pi over 6 simplified to 4 pi over 3. 9 pi over 6 simplifies to 3 pi over 2. 10 pi over 6 simplifies to 5 pi over 3. And 11 pi over 6 can't be simplified. So we filled in most of the radian measures here. We've done all the, almost all of them. Oh, and this is 0 or it could be 2 pi, right? The only ones we have missing now are the 45 degrees. So let's look at those in a different color. Okay, so from here to here to here, oh gosh. Oh, no, that's not going to work. Good enough. You get the point. So we've taken here, the top half of the circle here, and we've cut it into fourths. Okay, so this is 45 degrees. This is another 45 degrees for a total of 90. Another 45 degrees, another 45 degrees. Okay, so if we are cutting our pi, which is halfway around the circle, into fourths, pi we can think of as 4 pi over 4. So each is a fourth. So the first one is pi over 4. The second one is 2 pi over 4, but that's already been simplified to pi over 2. So we are done with that one. 3 pi over 4, already simplified. 4 pi over 4, we simplified already to pi. 5 pi over 4. 6 pi over 4, already been simplified. 7 pi over 4. 8 pi over 4, already been simplified. So we've got all of our radian measures now. Okay, I just realized I think I skipped something in the notes at the bottom of the page here. Did not? Yes. All right, this is kind of important. So there's not much to write down, but if you notice, sine, the relationship there is the opposite over the hypotenuse. If you look at the unit circle, the opposite measure, or the opposite side to this angle here is this side over the hypotenuse, this side. So the opposite side is the y value, and the hypotenuse, well, it's the hypotenuse, right? So the adjacent side is the x value. So what happens is the opposite side is y, and the hypotenuse is r. R is 1. That simplifies to just y. So the sine ratio is the y value, and the cosine is the x value. So the tangent is opposite over adjacent, so that ends up being y over x. So that's sine over cosine. These are things that you're going to have to memorize that relationship. That's good enough for now, but make sure you fill this in if it's not filled in your notes. All right, let's go back to the unit circle here. All right, so now that we've got these values, so let's go back to the original 30, 60, 90 triangle here, right? So just as we learned, the sine of 30 degrees should be the y value. The y value, this distance, do you see it's much shorter? That's the short side, is 1/2, right? The long side is the x distance, and that's square root of 3 over 2. So really what we're going to do is we're just going to reflect that short angle, and I'll do this in black, to the other short angles. And those values are going to be the same, except for they're going to have different signs depending on which quadrant you're in. So for the first quadrant, both sine, cosine, and tangent are all positive, and none of them are negative. We're in the first quadrant. Okay. In the second quadrant, the sine is positive because sine is the y value, and y values are positive there. The cosine is the x value. That's negative in the second quadrant. And tangent is sine over cosine. So if one of sine or cosine is positive and the other one is negative, then the second quadrant will make that value negative. So both are negative in this quadrant. And in the fourth quadrant, x is positive and y is negative. So all we have to do is take these values and give them the appropriate signs depending on which quadrant you're in. So I'm going to go ahead and press pause and fill in some of those. So if you see what I filled in is exactly the same values as over here in the first quadrant, except for now x is negative and y is positive. Again, x is negative and y is positive. So if you're trying to find the sine of 120 degrees, sine is the y value. So you would look at this. You can think of this special right triangle, okay? And this is the short distance. This is the long distance. The y value is going to be longer than the x value, and the y value is also going to be positive. So the sine, or the y, the sine of 120 degrees is root 3 over 2, whereas the cosine of 120 degrees would be negative 1/2. All right, let's go ahead and fill in the rest of this. All right, so notice both x and the y coordinates are negative in the third quadrant, which makes a tangent positive because tangent is sine over cosine. And if both of those values, negative over a negative, when you divide a negative by negative, you get a positive. And then I filled the rest in for quadrant 4 here. Just remember, I have this all filled out in the Google Drive if you want to take a look at that as well. And I also have blank ones if you want to practice. Okay, the last thing we need to do is right here. So a lot of times you're not going to have a unit circle directly in front of you when you're trying to figure out these values. And you kind of have to just quickly think about if it's a short angle, if it's a tall angle, etc. So the sine of 5 pi over 6, you would think, all right, this halfway around is 6 pi over 6 because that's equal to pi. So where is 5 pi over 6? 5 pi over 6 is, there you go. You just kind of, I usually write them down, but you don't have to. 5 pi over 6 is right about there, right? That is a short angle. And here they are. I wrote them down here at the top. Okay, those are the sixths. So sine, the y distance, which is y, is shorter than the x distance, and it's positive. So that is 1/2. Okay, sine of pi over 2. Where is pi over 2? Up here. The x coordinate for this point is 0. The y-coordinate is 1. So they're asking for the y-coordinate, which is sine, so it's just 1.